This section is going to be focusing on what are called neutralization reactions. So there are some chemical reactions and there are some steps that I've also left with you so you don't have to write these down, but these have to become part of your tool bank in order to solve some of these things. So first we're going to take a look at what a neutralization reaction is, and it's to make something neutral. So this is going to be our pH scale right here. So if you can go ahead and label this, here's going to be a pH of 0, and over at the other end, this is going to be a pH of 14. Of course, right in the middle we have our 7. And just to remind you, our acids are over here, okay, and our bases are over here. And of course, 7 is neutral. If you're trying to make something neutral and it's currently not neutral, you have to change the pH. So there's two questions. If you start off with a base, so here, let's say we have a strong base over here. And how do we neutralize that base? We want to bring it in this direction. We need to make it more acidic. So if you start with a base, what you need to do is you need to add an acid. And likewise, if we're over here, and if we start off with a strong acid, how do we neutralize that? We have to make it go this way. We have to add a base. So the goal is to make this neutral. If you have an acid, you add a base. If you have a base, you have an acid. This is one of the classic reactions of acid-base reactions. Let's take a look. Here is my acid, which is hydrochloric acid. Remember, acids always start with an H, and bases are going to end with OHs. So this is going to be sodium, and the OH is hydroxide. So this is sodium hydroxide. Well, let's see what happens when we put these two things together. This is going to fall apart. The HCl will fall apart into H plus and a Cl minus. Likewise, the NaOH will fall apart and it will produce an Na plus and an OH minus. What's going to happen when these are present in the solution? Well, the H and the OH are going to come together and they're going to create water. What will happen with these two? We're going to create the compound NaCl. So this is the classic reaction of taking an acid and a base. What do we get? So the products of a neutralization reaction are, our first product is water. Okay, so the first one is going to be water. And what's the pH of water? Water is neutral. We've just done a neutralization reaction, and we've created water, and we've created NaCl. NaCl is commonly called table salt. But when you combine an acid and a base, the resulting reaction of whatever we get over here, like calcium chloride or magnesium chloride or calcium iodide or calcium fluoride, magnesium iodide, any of those things actually are called a salt. So the two products of a neutralization reaction are water and a salt, not just table salt, but a salt. There are many different salts. Okay, so let's take a look at where the Na came from. Where did the Na come from, and where did the Cl come from? The Na came from the base. This is going to be the positive ion from the base. Where did the Cl come from? The Cl is coming from, it's a negative ion coming from the acid. Where did the H come from? The H came from the acid. Where did the OH come from? It came from the base. So with this information, we're going to start walking through the steps, and this is going to be a skill learned just by repetition over and over and over again. So what is the name and the formula of the salt produced from the following neutralization reactions? So we're going to do these two reactions here. We're going to follow these steps. We're going to do just what we did over here. So step number 1, find the charges of the materials using the reverse crisscross method. Well, how many NAs do I have? I have 1. So that means this is going to be a -1 over here. Now, OH is a polyatomic ion. It's the hydroxide ion. How many OHs do I have? The answer to that is I have 1. So my charges of the sodium are going to be plus, the OH is going to be a minus. Okay, now SO4, this is also a polyatomic ion. What's the charge going to be on that? When I do the reverse crisscross, it's going to be a 2. Remember, your first ions are going to be positive, your second ions will be negative, just like NaCl. This will be your positive ion, this will be your negative ion. Your positive ion is always first. There's going to be a 2 negative coming from the 2 here. What's the charge on the H going to be? It is not going to be 4. Remember, this is a polyatomic ion. This has 1 sulfur and 4 oxygens. I only have 1 of those. Remember, if I have multiple polyatomics, I have a subscript and I have a parentheses as well. Plus, in addition to that, H is always going to be plus, just like it is right here. OH is always going to be minus. So that's the first step. Determine the number of water molecules on the right side of the equation. So remember, we're forming water, and we're going to be forming some type of salt. Okay, so determine the number of waters that are going to be formed from this. So let's put our H2O right here. Now remember, what makes H2O? We have H pluses and we have OH minuses. Let's take a look and see what we have here on the left-hand side. How many H's am I going to have? And for this, we're going to be looking at the subscript right here, and that's going to be 2. So I'm going to have 2 H pluses. Now, remember, for every H, I'm going to have 1 OH. So if I have 2 H's, I'm going to need 2 OH's. Therefore, how many waters will be produced? If 1 H and 1 OH produces H2O, and I have 2 H's and 2 OH's, I'm going to be producing 2 H2O's, 2 waters. So to determine the number of water molecules on the right-hand side, that's what we just did. Now we need to balance the left side of the equation. Well, again, I have my 2 H's here, and I needed the 2 OH's. Well, here's my OH's, and I can balance, remember, using coefficients. So I'm not going to put a 2 there. I'm going to put a 2 over here. Write the remaining ions not used to make the water on the right-hand side, which we've just done, positive first and negative second. So what are the ions that are remaining? We've created the water. Now we're going to be using the sodium. So we have an Na, and the positive one gets written first. And the negative ion, which is going to be my SO4, gets written second. So now we need to use the crisscross method to make a legal compound. So what's the charge on the SO4? It's 2 minus. What's the charge on the Na? It's a plus. Now I'm going to use the crisscross method. That means this is going to be Na2, and I'll have 1 SO4. And the 2 on the Na balances the 2 on the Na over here. Okay, so now we just created this compound. This is the formula for this. What is the name? And the name is, what's the name of Na? The name of Na is going to be sodium. And we'll go through all of our polyatomics here on this as well, but the SO4, if you look at a polyatomic chart, this is going to be called sulfate. So that's our first one. So we're going to continue to go on to our next one. Okay? We're going to do the same thing, going through the steps. We're going to find the charges of the materials using the reverse crisscross. Remember, my H is always going to be positive. My OH is always going to be negative. Okay, how many H's do I have here? I have 1, so it's going to be a negative here. How many OH's do I have? I have 1, so it's going to be a positive here. This one is going to be a straight shot. Okay, determine the number of water molecules on the right-hand side of the equation. So we have H2O, and again, it's going to be formed from H pluses and OH minuses. How many H's do I have? I have 1. How many OH's do I have? I have 1. Therefore, I'm just going to be forming 1 water molecule. Now what we're going to do is we're going to use the remaining ions not used to make the water, and we're going to do the positive one first. Which of these is going to be the positive ion that's not used to make water? It's this one here. So it's going to be lithium, okay, with a plus, and the negative ion is going to be nitrate, and it's going to be NO3 with a minus. Use the crisscross method, and actually, since it's a charge of 1, it's a charge of 1, they are balanced. We don't need to add any subscripts to them, but we do need to have the name, and the name of this compound is going to be lithium nitrate. What I'd like you to do is now to attempt and try to do this next one by yourself. I'm going to allow you to pause it now, but we're going to continue going on. So I'd like you to try to do this because this one gets a little bit more tricky. So see how far you can get on this one. Then we're going to review it, and I'm going to do the same thing, and I'm going to pause for the fourth one for you to try to get the proper practice. So go ahead and pause it now and try this. Okay, hopefully you have tried that and you're coming back. We need to now first put the charges on everything here. So remember, my charges of my H are going to be plus, my OHs are going to be negatives. But I need to use the reverse crisscross to get the charges of the other ions. The charge of the CO3, you can look at a polyatomic chart, or you can just use the reverse crisscross, and this will show that it's going to be a 2 minus. Okay, the Mg, you can look at the periodic table. It's an alkaline earth metal, or you can do the reverse crisscross and say this is going to be a 2 plus here. Let's see how many waters we're going to create. So we're going to create, remember, water and some type of salt. What makes up my water? I have H pluses and OH minuses. How many H's do I have? I have 2. How many OH's do I have? I have 2. How many H2O's will I have? I have 2. Now let's use the other ions. We're going to be using the positive ion first, which is going to be the positive ion that was not used in water. It's going to be the magnesium with a 2 plus charge, and the negative ion, which is going to be the CO3, 2 minus. Now, do I need to do the reverse crisscross here? The answer is no, because those charges are opposite and they are balanced. What is the name of this? The name of this is going to be magnesium for the Mg, and the polyatomic ion with a carbon in it is going to be carbonate. Okay, the most complex one is coming up next. See if you guys can do this. Pause now and come back when you're done. Okay, hopefully you've paused, and we're going to go through and I'm going to start with my charges. H is always going to be plus. OH is always going to be negative. Let's do the reverse crisscross to see what's the charge on my PO4. The charge on my PO4 is going to be a 3. It's going to be negative because it's the second ion. Okay, doing the reverse crisscross, the charge on my calcium is going to be a 2, and it's going to be positive because it's the first ion. So let's now see how many water molecules we'll create from this. Okay, this is going to be a little bit tricky here. H2O. Remember, we have H pluses and OH minuses that create our water. Okay, now how many H's do I have? I have 3. How many OH's do I have? I have 2. Well, this is the first time we've seen this. In the first case, we had 2 and 2, and then we had 1 and 1, okay, and then we had 2 and 2. Now we have 3 and 2. What you have to do with this is ask yourself, what's going to be the common number between 3 and 2? And the answer to that is going to be 6. What's going to be the lowest common multiple of 2 and 3? It's going to be 6. We're going to have to form 6 waters from this. So in order to get 6 waters, I'm actually going to have 6 of these hydrogens. So I need 6 hydrogens, and I'm going to have 6 OH minuses. Okay, how many do I have over here though? I have 3 hydrogens. What coefficient do I need to put in the front to make it into 6? I'm going to have to make it into a 2. Okay, I need to have 6 OH minuses, and I have 2. Okay, here's my 2 OHs, but I need 6 of them. What coefficient needs to go in the front right here? 2 times 3 will give me my 6. Okay, let's go on and see what the ion that's formed from this. What's going to be my positive ion is going to be my calcium. Charge of the calcium is a 2 plus. My negative ion is going to be a PO4. What's the charge? 3 minus. Use the crisscross method like this, and it's going to be Ca3 PO4 2. Let's double check that over here. Do I have 3 CAs? I do. Do I have 2 PO4s? I do. And if you had difficulty doing this over here, if you had the correct ions like this, and when you transfer them over here, when you do the crisscross, this should tell you also what the coefficients should be for that equation, which would also help you determine the number of water molecules as well. So there's a couple different ways of checking your work on this. What's the name of this? We know that Ca is calcium, and a polyatomic ion, PO4, that begins with a P is going to be a phosphorus. This is going to be a phosphate. Okay, we're going to take a break and go to the next part.